Have you ever written an object that seems to have a split personality? One minute it does one thing, and the next it does something completely different depending on its internal status. Well, today we're going to talk about a super powerful design pattern that takes that exact chaos and turns it into clean, beautiful code. Let's dive into the state design pattern. Does this hit a little too close to home? Yeah, I thought so. If you've ever gotten lost in a jungle of if-else or switch statements, you know exactly how painful it can be to manage an object's behavior. This quote right here isn't just advice, it's basically a giant, flashing sign pointing us toward a much, much better way. All right, let's set the scene with a problem that I bet every single one of us has faced. You start with a simple object, but then it starts to grow, and before you know it, it's tangled up in this massive, messy web of conditional logic. It's that kind of code that becomes a total nightmare to maintain or even just to look at. And here is our escape hatch. The state pattern is the clean way out of that mess. The whole idea is actually pretty simple, but it's also kind of profound. You let an object change its behavior when its internal state changes. And the result is so dramatic, it's almost like the object has completely transformed into a different class. So how does this magic actually work? Well, the beauty of the pattern comes from a few key players all working together perfectly. Let's meet the team. First up, we have the context. This is our main object, the one your code is actually talking to. For our example, let's call it a person. Now, this person object has a state. Maybe they're healthy, maybe they're sick. But here's the crucial part. The person object itself has no idea how to act sick or healthy. It just knows what its current state is. And this is where things get really cool. Instead of jamming all that logic inside the person class, we pull it out into totally separate classes for each state. So we'll have a healthy state class and a sick state class. Think of them as specialists. Healthy state is an expert on what to do when you're healthy, and sick state knows exactly what to do when you're sick. All that behavior is neatly tucked away, right where it belongs. So how does it all fit together? Well, let's say your code calls a method like person.work. The person object doesn't actually handle that request itself. Nope. It acts more like a manager. It just turns around and delegates that request to whatever its current state object is. It's the state object, either healthy state or sick state, that does all the real work. And this is the big payoff, right here. The person class is now incredibly simple, it's clean, there's no conditional logic gumming up the works. All that complexity has been neatly moved into the individual state classes. So the person's behavior changes on the fly, but its own code stays stable and easy to read. It's really just beautiful polymorphism in action. Okay, so this pattern is really powerful, for sure. But that doesn't mean it's a silver bullet you should use everywhere. Knowing when to use it is just as important as knowing how. So let's talk about the specific situations where it's a perfect fit and where it might just be overkill. It really all boils down to complexity. This pattern is your absolute best friend when an object's behavior changes dramatically depending on its state. If you are staring down a monster if-else block, that's your cue. It's time to refactor. But on the flip side, if you only have, say, two states with really simple changes, this pattern is probably too much. A simple conditional is totally fine. And you gotta be careful. If your states aren't clear and well-defined, you could end up creating a whole new problem, an explosion of tiny little state classes all over the place. So, if you've decided that, yes, this pattern is a good fit for your problem, there are a few key things to keep in mind to make sure you implement it well. Let's run through a quick little checklist. Okay, remember these rules. The context job is just to hold a reference to the current state. That's it. All the real work, the behavior, and even the logic for switching to the next state, that should all live inside the state classes themselves. This is what keeps your context so beautifully clean of any if-else logic. And just one more warning. This pattern works best when you have a limited, predictable number of states. If that number starts to spiral out of control, you might be heading for trouble. So after all this, creating new classes, setting up all this delegation, is it actually worth all the effort? Oh yeah. When it's used in the right place, it's a total game changer. Let's just summarize the big payoff. This right here is what we were aiming for all along. We started out with that potential for total code chaos, a single massive class bogged down with confusing conditional logic. But by applying the state pattern, we get to code clarity.
Each state's logic is perfectly separated into its own class, which makes the whole system way easier to understand, easier to test, and so much easier to add new states to in the future.
So what's the final takeaway? The state pattern can give you incredibly clean, organized, and flexible code. But that clarity doesn't come for free, right? You're adding more classes, another layer of abstraction. So the real question for you to think about is, for your specific project, when is that trade-off actually worth it? Figuring that out is what separates the good developers from the great ones. Definitely something to chew on.